this function, if it has a negative on the inside, it's the same as cosine of 2x, since it's an even function. Since cosine is an even function. Just as a review, we already talked about it last week. And so I wanted to just go over because I didn't say it, but sine is an odd function. So that means if we have a sine of negative x, really it equals negative of sine x. All right. All right, let's do a little review. Let's see if we can remember what we talked about last week. Consider the following: y equals 12 cosine pi over x over 6. So what are the things that we pulled out before we graphed the trig function? What things did we talk about that you recall?
We're supposed to find the period.
Mm-hmm. All right, let's see. Okay, period. What is that formula?
2 pi over b.
All right, and we use 2 pi because the regular sine and cosine functions have a period of 2 pi. So 2 pi over b. And how do we find b? Where is b?
Behind cosine?
I don't want you to say behind cosine. Give me another way. Give me another way to explain it. Anybody else know another way to figure out where b is? Another way of saying it. I know what the trail is trying to say.
Behind the X.
Behind the X?
I mean, in front of it. I'm sorry.
Okay. So, Owen, what did you say? Did you say something, Owen?
I said in front of the X.
In front of the X? All right. So it's like the coefficient of X in a way. The coefficient of X. So this is the B. All right. So we have 2 pi over 6. And we definitely need to simplify that. So that's the same thing as 2 pi divided by pi over 6, which is 2 pi times 6 over pi. So what does that give us? What happens when we multiply 2 pi times 6 over pi?
You get 12.
12, okay. Because the pi's cancel. And we get 12. So our period is just 12, which is a little weird. Just a number, not even a pi. All right. And then, we found period last week. What else? What were some other things we found?
Amplitude.
Amplitude. And what's that formula?
Absolute value of a. Well, yeah, absolute.
All right. And where is a? Where can we find a?
A is in front of the cosine 12.
Yes, it's all right in front of that. So that's 12. What does the amplitude tell us, though? What does that tell us?
The distance from.
Sounded good so far. Okay, what you got? Finish it up. Let's see what
the distance from 0. I think that's what I meant to put.
I guess it's like the mid. I'm gonna start calling the mid line. And usually so far we've done a lot of the midline has been the x-axis. So the middle of the graph. Sort of like the max. Yeah, halfway above of the midline and below the midline. All right. So that's 12. All right. And just some other things. And I showed you different ways to break up this graph, but just showing you other ways that maybe you like better. For example, another way to divide up this graph. Now we talked about before, you put your 12 here and then you divide that in half, and we know that's 6, and then we divide that and we divide that. Another way is to divide the interval into 4 equal parts. Take the period that you found already and divide it by 4, because it's going to be 4 equal parts. So for example, our period here is 12. So let me put like a little formula. Period divided by 4. Period is 12. We divide it by 4. What do we get? 12 divided by 4 is
3.
3.
3. All right. And that tells us the distance apart from each section. All right. So let's put 1, 2, 3, 4. Trying to be equal here. 4. Then it'll be by 3s every time. 3. Add 3 to that. 6. Add 3 to that. 9. Add 3 to that. 12. That's just another way you can divide up your midline, or if you're on your x-axis into 4 equal parts. If you like that way, divided by 4. All right, we know that our amplitude is 12, so I'm just going to add like that's 12 up here. And what do we know about cosine and where our x-intercepts are? Y'all go back in your notes. Cosine, normally x-intercepts are where? Or where does it cross the x-axis is what I'm saying. Where does cosine cross the x-axis?
Is it 3 and 9?
Okay, at the quarters, right? At the quarters of the graph. Yeah. All right. Now we don't have a negative in the front. If we had a negative in the front, negative 12, that would mean that we would have to flip the graph. But since it's not a negative there, we're going to go with the normal cosine function looks like. So for the first point is going to be the high point. So it's going to be 12. And then that middle point is going to be that low point. All right. Then at the end, it's going to be high again. So it's going to be doing something like this again. This is one cycle or one period. Okay, and then we talked about last week different special type of distinct points. What distinct points did we talk about last week? 5 distinct points. What were those points called? What were the 5 distinct key points or critical points called?
Oh, talking about the intercept.
Yeah. Yeah. Okay. Tell me, what are the intercepts?
Y-intercept is 12, 0.
Is it 12, 0?
I mean 0, 0, 12. I'm sorry. 0, 12.
Okay. 0, 12. So that's a
X-intercepts
y-intercept.
X-intercepts is 3, 0 and 9,
Okay.
0.
X-intercept. Okay. 9, 0. Good. And the maximum values? Maximum points?
0, 12.
0, 12. Okay. Maximum.
And 12, 12.
12, 12. Maximum. Minimum point.
6, negative 12.
6, negative 12. Great. And obviously, this graph goes on and on and on forever. We're stopping, but it goes on and on forever in both directions. All right. We're just focusing on that restricted domain right there for the x-intercepts, max and min, y-intercept. All right. Any questions about that one? All right. Moving on. I wanted to review a bit about shifting from Math 112. So you may have heard of vertical shifting and horizontal shifting. So I kind of wanted to talk a little bit about horizontal shifting right now. Horizontal shifting. So for Math 112, you may have been asked, graph y equals x squared. What does that graph look like? Y equals x squared. Does anyone recall?
It like increases exponentially at like a 45-degree angle. So like y so if you plug in 0 for x, it would be 0. If you plug in 2 for x, you get y is equal 4, and then so on and so forth for every x value.
But there's a word for this particular graph. So this is a parent function. Probably one of those parent functions you were asked to memorize in pre-calculus. DeAndre, you gonna say something?
Oh, no.
Oh, okay. Anybody remember x squared? Yeah, y'all know this graph. Y'all are very familiar with x squared.
A
I know it. I
parabola.
just forgot the name.
Parabola. Yes, it's a parabola. It's a U-shaped graph called a parabola. All right, so yes, Rio, you were right. If you plug in 0, you get 0. Plug in 1. What would you get for y? Plug in 1 for x, you get
1.
1. Plug in negative 1, you get
1.
1. All right. So your graph looks like that normally. So that's y equals x squared. But recall you may have been asked to do some shifting. For example, graph y equals x minus 2 squared. What type of shifting? Vertical or horizontal? And how do we know? Y'all remember any of this?
I think it's vertical.
X minus 2 squared? Actually, it's horizontal. All right. Actually, it's horizontal, so I might have to go over what's vertical shifting. All right. So this is horizontal shifting because it's enclosed inside of this parenthesis. You see, this is enclosed inside of something versus if it was y equals x squared minus 2, that's vertical shifting. So this is horizontal shifting. This is vertical shifting. All right, this will be horizontal shifting to the right 2 units. It's opposite of what you think it's doing. It says minus 2, but it's going to go to the right 2 units. So it's going to, basically, I look at the bottom part as my anchor, and I move that bottom part over here. I shift it over horizontally. So this is x minus 2 squared in green here. What if I change it up to graph? Okay, that's a pencil. I didn't like that. Graph y equals x plus 1 squared. Is that horizontal shifting or vertical shifting?
Horizontal shifting.
Horizontal shifting where?
Left 1 unit.
To the left 1 unit. So you'll be over here instead, like over here in purple here. So that's horizontal shifting. Let's go over here and create a whole new one. So this is vertical shifting, meaning we're going to go up or down. Vertical shifting is exactly how it looks. If it says minus 2, we're going to go down 2 units. So your regular graph, I'm going to do that back over, was here. This was the regular one. But x squared minus 2 is not there anymore. It's shifted down 2 units. So it's going to be the same graph, but shifted down. All right, so that's the difference between horizontal shifting and vertical shifting. Horizontal shifting is usually enclosed inside a parenthesis or something else. Vertical shifting, that part at the end, that minus 2 is not enclosed. It's sort of like on the end of the function. It's not enclosed inside of the function. All right. So hopefully it's coming back a little bit from Math 112. The constant C in the general equations, y equals a times sine of bx minus c, and y equals a times cosine of bx minus c creates horizontal translations or shifts of the basic sine and cosine curve. So this right here, notice is enclosed inside of something. So this is going to be horizontal shifts to our graphs. All right, let's get started. It says determining endpoints when shifting. So when we have something going on, it's not just bx anymore. We have a minus c or a plus c. Then that means that we have some shifting going on, and we might have to use some more techniques to graph. So for the graphs of y equals a sine bx minus c and y equals a times cosine bx minus c, the left and right endpoints of a one cycle interval can be determined by solving the equations bx minus c equals 0 and bx minus c equals 2 pi. The reason why they use 0 and 2 pi is because for the basic sine and cosine functions, that's where our period was lying between 0 and 2 pi. So when we have a shifting situation, that occurs when we have that parenthesis and we got x minus something or x plus something or bx plus c, bx minus c. You have this situation where we need to figure out where are our endpoints? Because we are shifting. We're no longer at 0 and 2 pi like we've done in the past. We're shifting over somewhere. So here's how you're going to determine your endpoints. You're going to go with what they said here. So our bx minus c in this case is x minus pi. So our start point, start of our period would be x minus pi equals 0. And the end would be x minus pi equals 2 pi. And we're going to solve these, and these are our endpoints for our graph. All right, we're going to solve for x here. We have x minus pi equals 0. How do we solve for x?
Add pi on both sides.
Correct. Add pi to both sides. X equals pi. That's where we're going to start, at a pi. And then on the other side, we're going to add, same thing, pi to both sides. But what do we get in this case? X equals what?
2. Wait, it's 2 pi squared?
We're adding. It's going to be what? 3 pi. We add a pi to a 2 pi, right? 1 pi plus 2 pi is 3 pi. All right, again, it says divide the interval into 4 parts. How do we divide intervals into 4 parts? We take the period and divide it by 4. We take the period and divide it by 4. Now let's talk about the period. The period, we said, what was the formula again for period? Find the period of a function. 2 pi over b. And our b in this case is
1.
1. It's just 1. Yep. It's just 1. All right. And then we take the period and divide it by 4. So again, period divided by 4. 2 pi divided by 4. So this is going to help us figure out our increments. All right. So we reduce that down to what? What is 2 pi over 4 really?
Pi over 2.
Pi over 2. All right. So let's say we had some x-axis. Because we're shifting, we're not going to start at 0 anymore. We're going to look at our endpoints to figure out where we're starting. By the way, this is also known as your phase shift. That x equals pi right here. So we're going to start at pi. Now, where are we going to end up at according to our little calculation? We're going to end up at what? At the end of the phase, or the end of the 3 pi. What you could do is go ahead and put 4 tick marks, like 1, 2, 3, 4, because notice we need 4 equal 1, 2, 3, 4. 4 equal sections. All right. So we start at pi, and what we want to do is make sure we end up at 3 pi here. So let's see if we end up at 3 pi. We start at pi according to our formula for endpoints. And then what we can do is just add pi halves every time. All right. We just add pi halves. So if we have pi and add pi halves, what do we get to get the next radian on our x-axis? What is pi plus pi halves? What is pi plus pi halves?
3 pi over 2.
3 pi over 2 is correct. All right. So it's like saying 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2. Because pi is the same thing as 2 pi over 2. And then if the next one is 3 pi over 2, then this must be 4 pi over 2. What is 4 pi over 2 the same thing as? 4 pi over 2 is the same thing as what?
2 pi.
2 pi.
2 pi. Then 5 pi over 2. Then the next would be what? 5
6
pi
pi
over
over 2.
6. Yep, 6 pi over 2. And we know 6 pi over 2 is the same thing as
Pi.
6 pi over 2 is the same thing as what?
3 pi.
3 pi. So we ended up where we wanted to be because we said our end point was going to be 3 pi. All right. What we know about sine, we know that for sine, and we got to be careful, we're not going to start at 0 anymore because our graph has shifted pi units to the right, as y'all can see. Pi units to the right. This is horizontal shifting. So we're not going to start at 0. We're starting at pi now. And what do we know about sine and where the x-intercepts are? About where are the x-intercepts? Or where does it cross the midline? Or in this case, the x-axis. Where does sine cross the x-axis?
Ends and centers.
Yes, ends and center. So ends, that'll be pi and 3 pi, and the center would be 2 pi. Okay, we didn't even talk about the amplitude, did we? What is the amplitude? I guess we really have to talk about the amplitude, but what is the amplitude for this?
1.
1. Mm-hmm. That was kind of understood, huh? -1. All right, and then we know in between the x-intercepts for sine, for the first one, between those two x-intercepts is going to go up. Then it's between the next two x-intercepts is going to go down like this. So it's going to do something like that. So that's one period. And of course, it keeps on going on and on and on and on. All right. So that's how you graph that sine of x minus pi. Notice we didn't start at 0 this time because there was a horizontal shift. All right, and then I say graph sine and a function of graphing utility. So again, it'll be good if you go ahead and download Desmos as an app to your phone right now. DESMOS. And also a good one is GeoGebra. I think that's how Detrail pronounces it. But for whatever reason, Desmos has been the one that I look at the most. I don't know why, but when I look at GeoGebra, I was, oh, this is even nicer. All right. So I'm going to go to Desmos and let's see if we can compare the regular sine and see what we can, what's the difference really. All right, so this is regular sine, and then we just had a sine of x minus pi. All right, so in red was sine, it's doing that. And notice it's pretty much the same graph, but the one in blue was shifted over pi. That's why we got pi 0 right here for the blue one. Both have pi 0, but this one was shifted over. So it's not connecting because one is shifted over, so they're not the exact same. But as you can see, very similar graphs, just shifted over. All right. Going back. All right, let's practice finding the period and the amplitude of this next example, -3 cosine 2 pi x plus 4 pi. All right. Period we said was, and again, we use 2 pi instead of anything else because cosine and sine has a period of 2 pi. So 2 pi over b. What is b?
2 pi.
2 pi is correct. So again, if we had to write out that formula, y equals a cosine bx minus c, then the b is what's in front of the x, all right, or the coefficient to the x. So that's 2 pi. 2 pi divided by 2 pi, we know is 1. So we have a period of 1. Amplitude. Absolute value of a. So we have the absolute value of what?
-3.
4.
-3, which is 3. All right. So from the middle, this 3 just represents how many units we're going to go up and go down from the middle of the graph or the midline. All right, so the midline or the middle of the graph, if we locate where that is, then we go up 3 and down 3 from the middle. All right, let's talk about B. It asks for find the left and right endpoints. So to find the left and right endpoints again, we're just going to take what's in this parenthesis right here, and we're going to set the start to 0 because that's what sine and cosine normally start with, and the end to 2 pi because that's where cosine and sine normally ends at 2 pi. All right. So start 2 pi x plus 4 pi equals 0, and end 2 pi x plus 4 pi equals 2 pi. All right, 2 pi x plus 4 pi equals 0. Let's solve for x. What should we do first to solve for x?
Minus 4 pi on both sides.
Minus 4 pi on both sides. We get 2 pi x equals what on the right side? All right, somebody other than the trail since he's been answering. What's on the right side of the equal sign?
-4.
Yep, -4 pi. Then to solve for x,
Divide by 2 pi.
divide by 2 pi. Yep. All right, someone other than the trail and Owen. We will start where? Where are we starting?
It's -2 pi.
Is it pi though?
Oh, -2.
Because those pi's cancel out. So we start at -2. And I'm going to give you a minute to see where we end. So I want you to solve for the right end point. I'll give you 60 seconds to work on it. All right.
The
Where
endpoint.
say it again, Jasmine? The end point?
-1.
-1. Okay. Yeah. All right. Let's see. We're going to subtract 4 pi. 2 pi x equals -2 pi. Divide by 2 pi. X equals -1. All right. What did I say this is also known as? This right here.
Phase shift.
Phase shift. All right. Phase shift. All right. And it says this shows that the interval from -2 to -1 corresponds to one cycle of the graph. I thought this one was really interesting because it's all the way on the left side of the y-axis, -2 and -1. We're not even on the right side of the y-axis. All right. And also another formula for finding the phase shift is C over B, which is pretty much what this is right here. All right, if you think about it. So if we look back at what C is, again, this is BX minus C right here. C in this case must be -4 pi, if you think about it. C must be -4 pi in order for that sign to switch to +4 pi. So if we had to, if you wanted to work it out, the phase shift as C over B, then you'll know that C is -4 pi. And what is B? What is B again?
2 pi.
2 pi. And if we simplified this, -4 divided by 2 is -2. So if you wanted to figure out the phase shift from this formula, you could. But if you're doing the start and the left and right endpoints, then you already technically are finding the phase shift from the left endpoint. Okay, let's see if we can divide up this graph. All right. Now, how did we say we can divide? What little formula I gave y'all, just in case, is another way you didn't like, and maybe you like this way. What was the formula today that I showed you to divide into 4 sections, 4 equal parts? What do we
Period.
do?
Divide by 4.
Period divide by 4. All right, so divide the interval into 4 equal parts. All right, I'm just put a line here, put period divided by 4. What was our period?
1.
What? 1, okay. 1 divided by 4, so that's 1/4. Now our start point or our left end point is what again? What is our left end point? where we starting at would be -2. Then you could just do 4 little tick marks. 1, 2, 3, 4 again, because you just want, 4 equal spaces. 1, 2, 3, 4. And we gotta figure out what goes under the little tick marks, but you could just go ahead and put the 4 little tick marks. Now what this tells us here is you can add 1/4 to the first one to get the next one. You can add 1/4 to -2. So I want you to tell me, what is -2 plus 1/4? I want y'all to work that out for me. What is -2 plus 1/4?
-7/4.
All right. It's not pretty, but yep. -7/4. Okay. Let's add 1/4 to that. That might be a little easier to add 1/4 to -7/4 because they have the same denominator. -7/4. Okay, what you say?
-6/4.
-6/4. And what is -6/4 reduced?
-3/2.
All right. But keep that -6/4 because we like that. It has the same denominator. Okay, so let's write that down. If we add 1/4 to -6/4, what do we get?
-5/4.
-5/4. And then hopefully, what do we want to be at the end? What do we want to be there at the end? What do we want the end point to be when we add 1/4? Okay. Yes. Does it work if we add 1/4 to -5/4? Yes, right? -5/4 plus 1/4 is -4/4, which is -1. Okay. So notice we're all the way to the left. I'm gonna put the y-axis right here. We're all the way to the left of that. Okay, what was our amplitude again?
1.
Let's go back up.
Oh,
What's that? 3, right? So 1, 2. Let's just act like we put 3 here. Try to make sure it's even apart. Okay. So this is a cosine function. Okay, what do we know about x-intercepts of cosine functions? Where do they occur? Where do the intercepts of cosine functions occur?
At the quarters of the
Quarters. Okay. And what numbers represent the quarters of
-5.
-7.
Okay,
Good.
yep. Y'all both right. All right. So -7/4 and -5/4. Okay. You do know that. But we gotta be careful because this original, what we can't forget about the original, what is something that's gonna change some points around? Something about this function changes things. What is it? What am I talking about?
The negative.
Yep, that negative. That's going to mean that we're going to have a reflection. We're going to have a reflection. Okay. Eraser. So usually for cosine, we're up at the ends, but we're going to be at -2, we're going to be down. Okay. It's not going to be up anymore. It's going to be here. -2 And notice I'm trying to be even with the -3 over here, because that's our amplitude. All right, and then in the middle normally is down, and now we're up here. And on the end, normally we're up, and now we're back down. So let's say we over here somewhere. So it's doing something like this, okay? All right, what is the maximum? What
Negative
point?
3/2. Negative 3/2. 3.
Correct. -3/2, 3. X-intercept someone other than the trail.
-140.
You said 7/4.
Oh yeah, -740.
All right, -740. And
-540.
all right, great. Minimums occur where?
-2, 3.
-2, 3. -2, -3. All right, minimum. And
-1,
-1.
-1, -3. All right. Great. All right, let's see what y'all do with this one. I'm going to give you 5 minutes to see if you can work this out all on your own. Example 3, the function is -3 cosine of 2x plus pi. Give you 5 minutes to work on it. All right, what is the period of this graph?
Pi.
All right, pi. Again, that's 2 pi divided by 2 pi. What is the amplitude of this graph?
3.
3. Great. All right. Did y'all determine your endpoints? Because again, we got all of this stuff going on. And here we got a plus in there. If it's a plus or a minus, we know we're shifting. We're shifting somehow. So I want you to come up with the endpoints or the phase shift. All right, so endpoints. All right. Where are we going to start? How do I find the start value or radian or x value? How do we
X. 2x plus pi equals 0.
correct? And 2x plus pi equals 2 pi for the end. All right, we're going to subtract pi. We get 2x equals -pi. Divide by 2. We're going to start at -pi/2. All right, you tell me where we're going to end.
One.
All right, here's what we got to do. We got to subtract pi. When we
I got
subtract
+pi/2.
okay. All right, so 2 pi equals pi, because 2 pi minus pi is pi, divided by 2. X equals pi/2. All right, so now I want to know how to divide this up. So we're going to divide interval into 4 equal parts. Again, that's period divided by 4. The period is what again?
Pi.
Pi. All right. So we know we're going to do pi fourths distance apart from each other. Now we're going to start at negative pi over 2 though. Where is negative pi over 2 on this x-axis? To the left of the y or to the right of the y-axis?
It's to the left.
To the left, definitely to the left. Let's say it's right here, negative pi over 2. What do we need to do to find the next number, tick mark number that's important?
Do you
You
add?
add pi.
You add, y'all saying right, add what though? Add
Over 4.
pi over 4. Let's add pi over 4. That number we just got. Let's add pi over 4 to negative pi over 2. So y'all tell me, what is negative pi over 2 plus pi over 4?
Negative pi over 4.
Negative pi over 4. So that's still on the left side. So it's looking like it's doing negative 2 pi over 4, then negative 1 pi over 4, then 0 pi over 4, 1 pi over 4. So if you keep doing that, we got 0. That's the origin. Then we have pi over 4 right here. And then again, we have pi over 2. That's our end. That's where we're ending at. All right. Our amplitude we said was 3. So we're going to say that's 3 right there. Try to do it equal distance apart. So let's just say that's 3. Negative 3. All right, this is a cosine function. So what do we know about the x-intercepts? Where do they occur?
On the quarters.
The quarters. And what are the quarters here? What would you consider the quarters on the x-axis?
Would it be the negative pi over 4s?
Mm-hmm.
Pi over 4.
Yep. So we're there for that. However, what we got to be careful about every time before we just start applying some points, we got to look at the original to look for what? What would change something again? That negative, yeah. That's a reflection. So it's gonna flip what we normally do. It's gonna flip it. So normally for cosine, we start up, but now we're not starting at the top. We're starting at the bottom. So it's gonna be, our point's gonna be down here. Then we have our x-intercept. Normally in the middle, we're going down, but we'll go up here in the middle, in the center. And then at the end, we're going to go down again. So it's going to be doing something like this. All right. So I'm going to put this in Desmos just to see what's the difference between that and the normal cosine. Let's just see. So y'all see some vertical stretching, some shrinking going on. If y'all recall that from Math 112, that's the language that they're going to use in this section as well. So Desmos. This is regular cosine like that. And I'm not going to put the negative on first. Let's just see the difference between the positive 3 cosine 2x plus pi. See the difference. So notice that, okay, definitely stretched vertically, because in the green one, the regular cosine, the amplitude is 1. But in purple, our new one, the amplitude y'all can see is 3. The height from the middle is 3, and from and below is 3 from the middle. It looks like it was compressed horizontally, whereas the regular one was kind of spread out. This function was kind of compressed. All right. Now, what happens when we put a negative in the front? All right, let me take this one out. All right. And our focus was between negative pi over 2. And pi, we know to be 3.14. So let me see my calculator. So if I do pi divided by 2 in my calculator, that's 1.57. So negative 1.57. So if I trace this, negative 1 point, try to figure out where is negative 0.57. There it goes. So this is where we started with negative 1.57 at the bottom here, negative 3. And then we went up, and then we ended on the other side at positive 1.57, negative 3, which is the same thing as pi over 2. So of course, Desmond's going to show you everything, but we were only looking from negative pi over 2 to positive pi over 2, and only graphing that portion of the function. All right. This one I saw in the homework, and I thought they gave us a graph, and they said, describe the relationship between the graphs of F and G. Consider amplitude, period, and shifts. So I thought, why not just put it in the semi-guided notes so that we can talk about it. And I'm going to approach it as a true-false question, but of course it's not presented like that in WebAssign, but I want to discuss each one of the statements that they put in WebAssign so we can talk about it. So true or false, I'm asking you. Number 1, the graphs, y'all tell me what y'all think. The graphs of F and G differ only in their phase shift. Do y'all think that's true or false? The graphs of F and G. False. Why you say false? That's correct.
Because G is like more compressed than F.
Thank you. It's not the same, right? It obviously something else is different. It's yeah. G is definitely more compressed. If it was just a shift, it would look the same, but it would be moved over. But one is obviously more compressed than the other. All right, very good. Okay. Next statement, the amplitude of G is 2 times I don't know if I wrote that right. I'm going to say Well, the amplitude of G is 2 times. Hold on. Make sure I wrote that right. Look at homework. The amplitude of G is 2 times the period of F. That's what it said. 2 times the period of F. Amplitude of G is 2 times the period of F. What do y'all think? True or false?
It's false.
False. Oh, you had a question mark after that. Okay, why you say false? It's
Because
weird. Okay, go ahead.
period would be 2 pi and
Right.
amplitude would be 2.
And yeah, I'm trying to figure out why they putting this in the same sentence. But this is what the homework said. Okay. You said the amplitude is 2, correct? And you said the period is which one? Is 2 pi.
Both of them, really.
Okay, let's look at the one in blue.
Yeah.
All right. If y'all had to, would y'all say this is a cosine function or a sine function?
Maybe
Which
sign.
one?
Oh.
Sure.
Cosine?
It look like cosine to me. Cause how cosine it starts up here. Y'all know what I mean? It's up here like this, where sine does this. All right. So so from here to here looks like one period. Yeah, you're right. That is 2 pi. And for the red one here, it's smaller. It's pi halves on this side, pi halves on that side. If you add that together, that's like pi. So definitely false. We're moving on. It was a strange statement, but we're moving on to the next statement. The amplitude of G is 1/2 the amplitude of F. The amplitude of G is 1/2 the amplitude of F. All right, someone other than Owen and who answered the first one? Leo. What y'all think? Other than Leo and Owen, the amplitude of G is 1/2 the amplitude of F. True or false? Amplitude of G is 1/2 the amplitude of F. True or false? False. Boy, why you say false, DeAndre?
Because the amplitude for G.
You starting out good. Come on. The amplitude of G. That's the one in red. What is the amplitude? Somebody else. What's the amplitude of G?
It's -2.
It's
Well,
2,
we don't
right?
say we don't say negative, right?
Yeah.
The amplitude is the absolute value, correct? Amplitude of G is 2. What's the amplitude of F?
2.
2. Aren't they the same?
Yeah.
Yeah. Okay. Well, that's not true. All right, let's try. Let's see. Next one. The period of G is 2 times the period of F. All right, somebody other than Leo, Owen, Deandra, the period of G is 2 times the period of F. True or false? The period of G is 2 times. Just guess. All right, anybody? Other than Leo, Owen, and Deandra. All right, I'm gonna go ahead. It's false. Does Leo, Owen, or Deandra know why? They can explain.
All the point, like all the intercepts, the x-intercepts are the same.
But we're talking about period, though. The period.
Yeah, but like, so like the ink, like, don't you use the period to find the? So it's like period over 4, right? That's for the.
The period is one cycle. Where is it? It looks it periods when
Is it because their intervals are different?
I see what you're saying. But why is this statement false? So the period of G is 2 times the period of L.
Because they both span from -2 pi to 2 pi. So it would have to be false.
Well, here's what I want you to see. They're not the same period because y'all knows the one in red is skinnier, correct? It's skinnier. So, for example, isn't the G smaller? If we compare this right here to the one, this, isn't it big, F bigger? Y'all see it? We compare this cycle right here to this cycle. Then it's the reverse. Isn't the period of F like 2 times the period of G? Y'all see? It's like G is smaller. Y'all see it? G is not bigger than F. G is smaller than F. You see it? All right, me highlight. So this in red right here. See how skinny that is? It's almost half of the one that's in blue. Y'all see that? Half of it. So they have it in reverse, really. So that's why it's false. So we're gonna move on. Obviously, when you look at your homework and you find the other statement, that one's gonna be true. I'm not gonna tell you what it is. I want you to look at that. But as you can see, all of those were false. It was only one true statement in the bunch, and you can figure that out by doing your homework. All right, let's talk about this form again, because we are missing one element to this form, and that is the plus D part. That should be go on the end, plus D. So let's go back over what these letters help us with. So for example, this A is related to the amplitude. All right, the B part helps us with the period. So it helps us find the period. The C part is related to the phase shift. And this D part that we had talked about yet is related to vertical shifting. We talked about horizontal shifting, which is the phase shift, but we hadn't talked about vertical shifting. So that plus D on the end is that vertical shifting. For example, consider the following. F of x equals 3 times cosine x minus 2. So let's start off a little easy. And y'all notice that that minus 2 is not in a parenthesis. It's sort of on the outside of the cosine. This is not the same thing as cosine parenthesis x minus 2. Not the same thing. It's that minus 2 is on the outside. So this is an example of vertical shifting. Vertical shifting does exactly what you think it should do. Since it says minus 2, we are going to go down 2 units. All right. So we're not going to start at our normal x-axis anymore. We're going to shift down 1, 2. And I'm going to make it a dashed line. So really, this is where we normally would put things at on our x-axis would be on this line because we're shifting down 2 units. All right. Now, let's go ahead and find everything else that we normally find. So what is the period of this function? What is B? What is B?
1.
It's 1 because it's considered to be in front of the x, the number in front of x. So the period is 2 pi. The amplitude is
3.
all right. We definitely got to take a look at what does that mean for this graph because we've shifted down. All right. And then we want to divide. And let me just do this because we know we talked about endpoints before. And we normally talk about endpoints when we have that parenthesis. Really, our parenthesis is just x now, right? So x equals 0, right? And that's where we start. And we're going to end at x equals 2 pi because we don't have that parenthesis and we're not shifting horizontally. All right, so it's going to be the normal cosine period of 0 to 2 pi. But if you want to go through that formula, all you're just going to end up with is from 0 to 2 pi again, which confirms that it's the same thing as the regular original cosine and sine function. All right, now let's divide interval into 4 parts. So we got 2 pi, we divide it by 4, and we get pi over 2. All right, we're going to start at 0, but I'm going to put the pi 2 here, pi over 2 here. And then what would be the next? 1, 2, 3.
You add pi over 2.
Yep. Add power 2. What do we get when we add power 2 to pi over 2?
2 pi over 2 or
Or, yep. So it's like we're saying 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. So we ended at 2 pi where we wanted to end. But we're not going to put our points on the x-axis anymore. We got to put our points on that. We're going to call it the midline. This is our midline, right? This is where we're going to place our, we used to call them x-intercepts. but we're not going to call them x-intercepts anymore. They're not on the x-axis. All right, but it does still follow what we know about cosine. So it crosses, let's just say, it crosses the midline. Where does this function cross the midline? Cosine function, that is. Where does it cross the midline? We're not going to say x-axis anymore since we shifted. Where does it cross the midline? A cosine function.
Pi.
Pi, you say? Okay, let's do it back over. Okay, for cosine function. Remember we talked about sine, some crosses here, and cosine crosses here. Where do they cross? Let's go back to x-axis. Where does the cosine? Quarters. Okay, quarters.
Oh yeah.
Where
Sorry.
would you consider? That's fine. Where do you consider to be the quarters?
Over 2 and 3 pi over 2.
You said pi over 2 and 3 pi over 2? Yes. But I'm going to put it here now, not the x-axis. Right? Quarters right here. All right. Here's the little weird part. Since we shifted down 2 units, our amplitude is not going to be where it usually is when we just put a 3, just stuck a 3 up here. No, we're going to go up 3 units from where we are. So if we're at -2 right here, if we go up 3 tick marks, 1, 2, 3, put one right here. So that's 1, 2, 3. Where are we? Where are we?
+1.
Okay. And then if we go down 3 tick marks, 1, 2, 3. Where are we?
-5.
-5. So here's a way you could do it. You started at -2. You could add 3 to get 1. And you also could subtract 3 to get -5. Okay. That's how you can get your max and min. All right. We also know that cosine, for the regular cosine, you start up. Your first point, you start up. So it's not going to be at 3 anymore. Our top y value is going to be 1 now. Then in the middle, for pi, we're going to go down to -5 now. And then on the end, we're not going to, again, be at 3. We're going to go back up to 1. This is our max. So it's doing something like this, right? This is graphing one period of the graph. All right, let's go through some things. Is there an end? Well, there are, but we can talk about it. Let's talk about y-intercept first. Do we have a y-intercept?
Yes.
What is it?
0, 1.
0, 1, y-intercept. All right. We actually do still have x-intercepts. We just don't know what it is, right? How do you normally find x-intercepts? And this is going to be a sidebar. How do you normally find x-intercepts? You have a function, and you're asked to find the x-intercepts. Anybody remember? Or zeros.
Where it crosses the x-axis.
Correct. But see how we don't really know what it is, right? Y'all see those are x-intercepts. Let me highlight it. Definitely are some x-intercepts on here. I'm just trying to figure out how we can find out where they are. Okay, if we have a function, let's say your function is 3 cosine x minus 2. How do you find x-intercepts algebraically, not graphically? Does anyone recall how to
Set
find
the function equal to 0.
Set the function to 0 or set the y to 0. All right, so for example, 3 cosine x minus 2 equals 0. This is a sidebar. I might be getting a little ahead of myself, but let's go ahead and get done. And we're going to solve for x. What would you do first to at least try to isolate cosine?
Move the
How?
2 over.
By doing what?
Or adding 2 to both
Yeah.
sides.
Yep, let's add 2. That's 3 cosine x equals 2, and then you would...
You say you're trying to get cosine by itself?
Let's get cosine by itself.
Divide 3.
Divide by 3. So at least now we got cosine of x equals 2/3. I hadn't taught you this, but I'm gonna go ahead and tell you. If we want to just get x, all right, if we just want to get x, we have to do the inverse of cosine. So x will equal cosine, that little -1, raised -1 like an exponent of 2/3. We do the inverse of it. All right, and your calculator, we need to figure out do you have a cosine to the -1 located on your calculator? Mine's is where cosine is, and on the actual calculator, I see in blue on mine's cosine of -1. All right. So I need to change my mode to radian, not degree. Cosine of 2 divided by 3. So x, see if y'all get approximately 0.841, something like that.
Yes, ma'am.
Yes.
So this is like, so they're saying this is like 0.841, comma 0. All right. And does that make sense? Because what is pi over 2 in your calculator? What is pi divided by 2 equivalent to? Pi divided by 2 is, that's the next little tick mark on the graph. What is pi divided by?
1.571.
Yep, approximately 1.571. Okay, so if that's 1.5, then that makes sense. That's sort of like halfway in between, as y'all can see. So that seems about right, that x-intercept right there. All right. And the other way to get this part over here is if you know that this is 2 pi, this is symmetric. This graph is symmetric. This 2 pi right here, all we really have to do is let's take 2 pi and subtract that 0.841, for example. What is 2 pi minus 0.84107? I put as many as possible. Should be about 5.44, something like that. Okay, so that's about 5.44, comma 0. So you can get the x-intercepts if you wanted to, but I might be a little ahead of myself on that one. All right, what is the minimum point? What is the minimum point?
Pi -5.
Pi -5. Give me another maximum point. Give me
2 pi
another
1.
2 pi 1. 2 pi 1. Good. Great. All right. Anything else I wanted to say about that one? No. Other than this is also a maximum up here. The y-intercept was a maximum. All right, let's try this one. And then we'll try a hard one, and then we'll move on to try to touch on the next section. Consider the following. F of x equals 4 times sine of 3x plus 3. Do we have horizontal shifting? Do we have any horizontal shifting for this one? Yes or no?
Yes.
Horizontal shifting?
No.
Not necessarily. Not necessarily. All right. Because horizontal shifting is when you have that minus C or plus C here. All right. That's phase shift. Do we have vertical shifting? Do we have vertical
Yes.
shifting? We do have vertical shifting. That's from that last little part hanging out, not connected to the sine. All right. We do have vertical shifting. Are we shifting up or down?
Up.
Up 3 units. All right. Great. So we're not going to be on the x-axis anymore. We're going to shift up. Let's just say 1, 2, 3. Let's say we're here. I'm going to create a little dotted line right here. That's our midline, not our x-axis anymore. All right, I'm going to erase this stuff over here. Hopefully you got it. It's in my way. All right. All right, now let's go through all the things. All right, period. 2 pi over b. What is b?
3.
What? 3. All right. Amplitude. Absolute value of a. What is a?
4.
4.
4. All right. Next. Again, if you want to do endpoints, when you don't have that horizontal shifting though, it's just going to be 0 to 2 pi. But let's go through it. Endpoints. Start. What are we setting to 0 for the start? The left endpoint. What are we setting to 0 for the left endpoint?
3x.
Yep. So 3x equals 0 and 3x equals 2 pi. So x equals 0, divide by 3, x equals 2 pi over 3. All right, so we start at 0. We're going to end at 2 pi over 3. And we divide. How do we divide our interval into 4 equal parts?
Period divided by 4.
All right, our period is a period divided by 4. So period is 2 pi over 3 divided by 4. What is that? What is our period?
2 pi over 3.
You said the period divided by 4, right?
Yes, ma'am.
So what is 2 pi over 3 divided by 4 then? Divided by 4. Anybody? 2 pi over 3 divided by 4. All right, trig class. They're just fractions, right? Just fractions. What is 2 pi divided by 3 divided by 4? You got it.
Two pi over 12.
2 pi over 12 is correct, which reduces to
6.
pi over 6. All right, so our start point is 0. Start is 0, but we're going to divide it to pi over 6. So pi over 6, add another pi over 6. Where are we?
Two
Pi over
power
6.
6.
2 pi over 6, which reduces to,
Power 3.
Mhm.
all right. Then we got 3 pi over 6, which reduces to 3 pi over 6,
Power
which
2.
reduces pi over 2. He said 3 pi over 6. Now we have 4 pi over 6, which reduces to
Power 2.
4 pi over 6. Do it again. 4 pi over 6.
2 pi over 3.
2 pi over 3. That's where we wanted to end, right? 2 pi over 3 because of our period here. All right. This is a sine function. Okay. For sine, for regular sine function, where does it cross the x-axis normally? But now we got to cross at the midline. Where does the sine function cross the x-axis normally? But now we're going to cross at the midline because we shifted. Where does it normally cross? The sine function. So go back to your notes. Where does the sine function normally cross?
The quarter.
Ends in center.
Point.
Ends and center. Ends and center. All right. Where is the end? What end are we talking about here? When x equals what? What end are we talking about? The first end, I guess. Where's the first end? When you say end.
3.
0.
0. Okay. 0. 0, 3. All right. And 2 pi over 3, 3. Okay. And then the center. Where is the center? Mine doesn't look like the center, y'all. So supposed to be pi over 3, correct?
Yeah.
That's supposed to be the center, but mine not looking too good. All right. Maybe push it over a little bit. Okay, now we need to know, because of this amplitude right here, that tells us from the midline 3, we're going to go up 4 units. Let me try to erase this. Go up 4 from 3. 1, 2, 3, 4. Where are we? We go up 4 from 3.
7.
7. And if we go down 1, 2, 3, 4, where are we?
-1.
-1. Okay. Again, you could just start with 3, add 4, start with 3, subtract 4 to get these numbers, max and min. All right.
You getting a 3 from the period.
From that where we shifted, it's plus 3.
Okay.
That D part.
Okay.
That's our middle now. Instead of 0, usually our x-axis is 0. That's usually our middle, but when we shift it up, now our middle shifted up too. All right, and then for sine, if that first number is not negative, then it's gonna follow the same look of the original sine function. So in between these points key points that we have right here, we're gonna go for the first 2 points, we're gonna go up to 7. Let's change my color if it will let me. Okay. We're going to go up to 7, and then for the points between the last 2 points that we just plotted, we're going to go down to -1 since that's our minimum. All right. So we're going to go up, and then I don't know why it's erasing. Try it again. Up. I don't know why I did that. It's acting funny again. It does that. I don't know why it's doing it, but y'all get the picture. All right, so that's where it's supposed to. It's supposed to be like this if you catch it. It's supposed to be like this, but it's gonna erase it for some reason. All right. Maybe I'll try one with a lot of things involved, and then we'll move on. Or should I just move on? How y'all feel about this section? Y'all think y'all got it? The shifting? We don't have to do an extra one. We can just move
I
on.
don't think I got it.
You don't think you got? Okay. I'll do one more. And then we're going to move on to 2.6 after that. So let me go to the whiteboard where I have some more space. All right, let's say we have y equals 3 times cosine of pi x plus pi over 2 minus 2. Find the period, the amplitude, and the phase shift. All right, ... That's good enough. So I'm going to give you 2 minutes to find the period, the amplitude, and the phase shift starting now. Let's see how well it goes. And then I'll give you some more stuff to do. All right, period. 2 pi over b. What is b?
Pi or 1.
Pi, right? All right, and then pi's cancel. So we just have 2. Amplitude.
3.
All right, great. And then for phase shift again, you can do the endpoints. And where you start, go ahead and do your endpoints. Where you start is your phase shift. So that's pi over x plus pi over 2 equals 0. You're going to end at pi x plus pi over 2 equals to 2 pi. All right. All right, so that means we need to subtract pi over 2. Pi over x equals negative pi over 2. And then we need to divide pi over 2 by pi. So what do you get for the phase shift? X equals what?
Would
Power
it be
2.
negative 2?
Say it again. A couple y'all said something at the same time. What is it?
Power 2.
That's negative power 2. Okay, go ahead.
Why are you getting the when you put negative power over 2, then you divide by pi? Where did pi come from?
Hold on. Doing some weird. On the left side is pi x, so you divide by pi to get x by itself.
Okay, I get what you're saying.
You see it? Okay. Okay, so
Negative 1/2.
yes, negative 1/2. So y'all gotta get real chummy with fractions. I see. All right, because it looks like with trig, that's all that's happening. Fractions. So that's if negative power 2 divided by pi is the same thing as negative pi over 2 times 1 over pi, which means that we need to cancel the pi's, leaving us with negative 1/2. All right. So tell me, what is the end over here? End. X equals what? Start with negative 1/2. Where are we ending? All right.
1.
Let's do it together. All right. We got to subtract pi over 2. Subtract pi over 2. So that's pi x equals. So 2 pi is the same thing as 4 pi over 2, which is 3 pi over 2. And then you got to divide by pi again. So that's x equals 3 pi over 2 divided by pi, which is 3 pi over 2 times 1 over pi. The pi's cancel out, leaving us with x equals 3 over 2. Okay, so let's go back over this again. For the period, what was the period? It's just as a review what we did so far. What's the period?
2.
2. 2 is correct. The next question, what's the amplitude?
3.
3. Correct. Okay, 2, 3. All right, next. What's the phase shift?
1 over 2.
Negative 1 over 2.
Sorry, negative 1 over 2.
Yeah, it's the first one we get to. Okay, if I ask you what's the left end point, what would you say? Ooh, I got y'all.
Negative 1 over
Negative
2.
1 over 2.
Same thing. Right. This is the left end point. So negative 1 over 2. What is the right end point?
3 over 2.
Yep, 3 over 2. Right end point. Okay, let's see what else we can get out of this. All right, so let's attempt to graph. Let's attempt to graph. All right, we're going to start at negative 1/2. That's over here somewhere. Negative 1/2. And then we got to figure out how to divide this by 4. So what are we dividing? What are we dividing to get the 4 equal parts?
Add the period by 4.
Yep. Period. Divide into intervals, to say it like that. Period divided by 4. And what's the period again?
2.
2 divided by 4 equals
1/2.
1/2. So we start with -1/2. That's our left endpoint. -1/2. Then we're going to add a half. Where are we when we add a half?
0.
0. It's 0. Then we add a half. Where are we?
1/2.
1/2. 1/2. And we add a half. Where are we? We add a half to a half. Where are we?
1.
1. And then we add another half. Where are we?
3 over 2.
3 over 2. That's where we wanted to end. That is our right endpoint. All right. What's our amplitude?
3.
Is that 3? Okay. But we're supposed to be shifting somewhere. Where are we supposed to be shifting?
Down 2.
Down 2. From this part right here, this is a vertical shift. Down 2 units. So I'm going to create a little dashed line at, let's just say that's -2. Let's do a little dashed line right here. Okay. All right. What function are we dealing with? Cosine function. Okay. Cosine function. It's not a negative in the front, so it's going to do exactly what the original does. For the x-intercepts, where are the x-intercepts normally for a cosine function? X-intercept.
Quarters.
The quarters. What would you consider to be the quarters here? The quarters.
-1 over 2 and 1.
0
Or
and
is it-
1.
0 and 1. I know I didn't put that 0. I tried to put a little orange one there so you can see. So really it would be at 0. These are the quarters right here. Okay. Now, okay, so this is -2 right here. Because of our A, the A in the problem, we have 3. We need to go up 3 from there. So 1, 2, 3. Where are we if we go up 3 on the y-axis?
1.
1. And if we go down 3 from -2, 1, 2, 3. Where are we?
-5.
-5. Okay, so again, you could just take that -2 where you shifted from, and you could add 3 to get to that 1, and you could subtract 3 to get to that -5. All right. So for cosine, on the end, we start at the top. So the end, we got -1/2. So that must mean we have -1/2, 1. And then in the middle, center, 1/2 will be down here, all the way down here to -5. And then at 3/2, we're going to go back up to 1. So it's looking like it's going to be doing something like this. All right, hopefully that was better. But that's what homework is all about. So practice on homework, see if you get it, and then we can discuss that 4.5 on Thursday.